Basically, our agenda today is we'll talk a little bit about why we're here, why does mobile web performance matter, what's the impact of that. We'll talk about the different aspects of mobile, certain view on how can you slice and dice the big mobile world and to understand the different components it has, and then we'll drill into each one of those components and talk about the performance implications in Briggs with it, and talk about what can you do about it and techniques. At the end of that, we'll summarize and we'll open it up for questions. As Yasmina mentioned, you can ask questions as we go, and what I'll try to do, if I'm not too behind on my time management, is to actually stop at the end of every section. We have about 4 of those here, and try to take those questions then if they're not overly long. So with that, let's get started. Before we really dig into the material, a couple of words about who I am. So I am Guy Podjarny, or Guypo, and I used to be, up until a couple of months ago, the CTO of Blaze.io, which has been acquired by Akamai. And what we do is a solution called front-end optimization. So in a sense, what we do is meant to save you the need to understand some of the things I'm talking about today. Because we manipulate the pages and the resources on them to accelerate them for mobile and desktop experiences as we go. That said, I'm a big fan and believer that you need to know what you're doing, even if you are using an automated tool, understand what it's doing. So we've been doing a lot of these types of presentations. Beyond that, I also am sort of the primary writer of the MobiTest solution, and this is a web performance measurement solution that is a free online service that you can find if you go to akamai.com/mobitest, and where you can punch in a URL and see how long it takes to load on a certain on a variety of mobile devices that we have. I'm happy to say that we've actually open sourced this tool last week, I believe. So it's out there right now. When we share those slides, you'll have that link, but you can find it on our blog as well at blaze.io/blog, and you can actually install this. I'll talk about measurement a little bit later, so you can install this on your devices. So this is another aspect of where I'm coming from when I talk about mobile performance. And then the last leg is what I'm doing here. So I do a lot of research about mobile performance. So that's just a couple of moments about who it is that's speaking here. And then one last thing before we dig in is just some terminology. So during the presentation, I'll be talking about waterfall charts. These are screenshots similar to what you see here on this slide. They are basically visualizations of a load of a web page, and they try to illustrate a lot of information in a concise format. In sort of believing in the picture is worth 1,000 words. So you see a lot of individual requests here. Every line is a resource request, a JavaScript, an image, something of that nature requested by the page. And you see them over a timeline. And we would also talk about 2 points in time during the waterfall chart, during the loading of a page. The first one is start render, and that's this green line. And that's basically the point in time when the user stops staring at a blank white screen and something shows up. Something starts displaying. And then the blue line is the document complete. That's the point in time your browser said, okay, the page is loaded, it stops showing progress indicators. Technically in the HTML, it's the onload event or the doc complete time. So those are just terms I'll be using through the presentation, so I wanted to make sure they're aligned. Okay, with that intro, let's jump in. So a little bit about why we're here. So at the bottom line, users expect fast sites. This is a study, I believe this is about a couple of years ago, a couple of years old, a study by Forrester commissioned by Akamai, which surveyed users and checked how long are they willing to wait until a page loads. And the result of that and various similar studies has been the majority of users, give or take, expect websites to load in about 2 seconds. That's a pretty high bar, and exactly what is a loaded page is not clear. But what is clear is that users expect a very fast form of interaction. They load a page, they want it to load quickly. And if you don't give them that fast site, they would go away. they have a lot of alternatives on the internet today, and they would switch to a competitor site. This is a curve from data provided by Kissmetrics that shows abandonment rate by page load time. And you can see that as the load time increases, the abandonment rate increases. And the easiest way to visualize this is thinking about, running a Google search, and you click on the first result most likely in that search. And if the page doesn't quickly load, you probably do back and you choose the second result. It basically, our patience and our willingness to wait today is decreasing. I definitely know I do that. So if you don't do it, they go away, and if you do it, they give back. Users, there have been many studies that show that if a website is faster, users like it better, and as a result, eventually perform better as users from a website perspective, whether that's more conversions and purchases in an e-commerce site, more return visits and page views for a media site, etc. And they really give back. The other aspect is that fast sites tend to be lean sites, and therefore they're more available. They're usually lower cost to maintain, etc. So fast is good, and fast websites are really significantly better than slow websites. What about mobile? So mobile browsing and the mobile web is growing dramatically. These are a few months old. I think these stats are actually quite bigger today, where you're looking at a few specific sites, Facebook, Twitter. This is the Financial Times website. All of those have very, very significant amount of traffic on their websites, and not just for mobile devices, but specifically through the mobile web. The browser is the most used application on any mobile device, pretty much, and those trends are growing, and the mobile web is definitely going to surpass the desktop web. In some regions it already has. So mobile browsing is very significant, and mobile users expect basically the same speeds that we do on desktop. There have been a couple of surveys here. The questions are a little bit convoluted, but it basically says, do you expect your phone to be, how long do you expect pages to load on your phone as compared to your desktop? And basically most users say, I want it to be at least as quick. And when you think about today's world with iPads and tablets, that's even more so, right? Really, what's the difference in the user experience and expectation when you launch an iPad and you load a page versus load your laptop and open up that page? So they expect a fast site, and once again, if you don't give it to them, stats are similar around abandonment. It does seem like there's a little bit of tolerance about the startup time being a little bit longer. So there's a couple of seconds more that we may be able to afford. But definitely we want to push this forward. So we need fast sites, and we need fast mobile sites specifically. Let's talk, when you talk about performance, you talk about load times. There are many moving pieces. There's a lot that happens between the time you punch in a URL or select a bookmark and the time the page is fully loaded on your browser. Very simplistically, you can split that up into back-end and front-end, thinking about the back-end as the time it took to actually generate the page, and the front-end, everything that follows. So you got the page, and now scripts on the page run, CSS files are downloaded, images are being fetched, the browser needs to build the DOM to move objects around. All of those components are considered the front-end. At least that's the term I'm using here in the presentation. And today they account for, on most websites, 80 to 90% of the actual page load time. So the bottleneck, we put a lot of effort into server infrastructure, into load balancers, into databases, and today the bottleneck has shifted, and it's primarily in those components where a lot of these moving parts and richness of pages happens. And this trend has been pretty safe. Actually, Steve Souders recently had a blog post that just revisited this assumption, and it proves to be true still. And it definitely is still true on mobile as well. Okay, so that was a little bit of background that I was intentionally going quickly through just to say, why are we here? Why are we talking? Basically, we're here and we're talking about this because speed matters and mobile web performance matters, and it would result in a significant improvement or modification to your bottom line if you actually ensure that your sites are better. However, when you talk about mobile, it's a really, really big term. And when you sit down to say, well, how can I address mobile performance, the topic or the interpretations that people can give mobile performance are vary greatly. They're too varied. It's too broad a term. What we find useful is primarily to split that term into three top categories. We can talk about mobile network, the cellular networks that are different than the broadband networks. We can talk about mobile hardware, the actual devices that you carry around that are different. An iPad and iPhone is different than your laptop, than your desktop. And we can talk about mobile software. Basically, those mobile devices come in with their own operating systems, with their own browsers, and they are differently tuned and they're different in certain characteristics. So I tend to think about mobile in these three buckets, and that helps me address questions like, is an iPad on Wi-Fi, is that mobile? Well, that involves mobile hardware and mobile software, but not mobile network. What about an iPad, a laptop tethered to a 3G connection? That's the mobile network, but it's not the hardware and software. So it helps a little bit when we address that. And specifically, it helps talk about the performance challenges and opportunities that each of these sections opens up, or each of these categories creates. So for the rest of the presentation, we'll basically dig into each one of these three and talk about the problems and the opportunities that we can take advantage of in those areas. Let me take a quick peek here in the Q&A. Okay, I'm still learning a little bit the system. So I see one question about, are these load times for the browser? I suspect expectations for apps are different. Definitely. Measurements, in general, to measuring performance is a very complicated topic by itself. There's no single point in time that is generic and true for all applications about when is your page fully loaded. There's this logical point in time people talk about, which is when is the page ready to be interacted with, when is the majority of content available, and that is even more complicated to measure for apps, for websites that are really rich HTML5, AJAX applications, and they just load up the initial page and then they measure from there. The techniques and the challenges I'll be talking about are applicable no matter what your measurement technique is. The actual measurements and load times that I'm talking about the generic loaded indicator by the browser. So it's a good enough general term to work towards. When you look at your specific application, I would definitely recommend that you track to a more logical point in time when a certain element or a certain visible or interactive component is loaded and ready to be used. Okay, on to mobile network. So the primary characteristic of mobile networks is that they are slow. They're slow. They have lower download rates than your average broadband or DSL. They have slower upload rates, and those differences are quite substantial. They're also very, very inconsistent, and I don't talk about that too much, but there's a big difference between being the only LTE user in your environment and in your area and sitting by the antenna and using your latest generation Android phone versus being in a rural area using a slightly older phone and being or being in a crowded network when you step off a train or when you're in a sports stadium in the middle of a game. So there's a very large volatility, but there are a lot of stats being gathered about averages and about medians, and those definitely show that download and upload rates on mobile networks are significantly slower than the ones that are on your desktop device. The other very significant characteristic of mobile is high latency. Averages I've found talk about 300 milliseconds. Again, those are averages that are broad, but even if you look at local areas and high reception areas, generally in mobile, if you get 100, 150 millisecond latency to the internet, that is the time it takes to get packets from your device to the internet and back. Those are if you get 100, 150 in mobile, that is considered not bad at all. On desktop, those would be considered terrible. So mobile networks are slow and they're very, very high latency. So it's a clear problem, and it's one that we need to deal with. What can you do about it in your website if you want to make your pages faster despite that limitation? So really the top recommendations are very big, which is reduce requests and reduce bytes. Both of those have a variety of techniques, and I'm not going to get into them, but I'll talk a little bit about why. Reducing requests implies trying to avoid these round trips going from your from the browser, from the client, to the server and back. Every time you fetch an image, every time you fetch a CSS, that's another round trip. Every request is a round trip, and when you're in a high latency environment and when you add on a slow upload rate, it creates a lot of overhead to each one of those requests. So being in those types of environments creates, while it's generally useful to reduce requests on desktop, being in this environment of a mobile network makes the cost of having those extra requests even bigger. So you want to really make an effort to try and reduce the number of requests, merge together multiple CSS files in JavaScript, try to avoid requests that can be done later, etc. When you talk about reducing bytes, that is actually a slightly more intuitive optimization. Basically, it takes less time to download 100K than it does to download a megabyte. When you're in a slow network where download rates are smaller, it is more important for you to reduce the actual amount of data that you're sending down. And then when you're thinking about these things, again, assume a bad reception edge connection, not some new phone in the middle of the city using LTE. Most of your users are not using those cutting-edge phones and cutting-edge networks. Maybe that equation will change over time, but today that is the case. So you definitely want to concentrate on reducing requests and reducing bytes. And there's a lot of great material out there about the specific techniques. Here's a specific example of an optimization you can do, which we call images on demand. It's sometimes referred to as lazy loading of images. The idea here is that you would only load images as they scroll into view or as they get loaded into view. So a lot of the content on your screen is actually below the fold. It's actually in the areas that users don't see. Most users actually don't browse down, or they don't browse to the end of the page. So not downloading those requests that are below the fold can really make your load time significantly faster. There's no saying that you shouldn't download those images after the fact, but if you want to load the parts that are visible faster, using images on demand can significantly reduce both the number of requests and the amount of bytes that your page requires to load. This is an example of the Walmart apparel page, and it's a little hard. I'll actually skip to the next slide, and I'll talk a little bit about the effect, is that by applying images on demand, we've basically managed to reduce the number of requests by about a third, reduce the number of bytes by about a third, and reduce the actual load time by a good 2/3. And that is pretty consistent. I have very similar slides about MSNBC Sports, but a variety of other cases. Those are actually very, very common stats. So that's a good example of an optimization that reduces both requests and bytes. Later, you can download those components, but at least don't allow that content that's below the fold to delay the content that's above the fold. So that's one example. So mobile networks are slow. What else are mobile networks? The second characteristic I want to highlight is that they are also unreliable. If you weren't dispirited enough by how slow and high latency those networks are, they're also unreliable, right? If you've had the experience of stepping off a train, off a subway, and you have 4 bars, but you can't get a single data bit out. You can't browse a page, you can't get an app to work, you can't get your email. And that's because of packet loss. You get into those very noisy environments, for instance, something where there's a surge of new devices connecting to this tower, and you can't get anything done. Packet loss is extremely variable. Sometimes it's low, sometimes it's very, very high, like those scenarios I explained. But it's definitely something that is, on average, much higher than it is on desktop. And it's easy to understand, right? You are a moving client. You move from tower to tower. You're out there communicating over the air. There's a lot of other things and noises and interruptions that happen over the air. There's a very inconsistent load on different towers. So it definitely is a characteristic of mobile networks that you have to address. The best thing you can do to address this problem is to try and eliminate single points of failure. The ideal is try to make every component on your page as independent from the others as possible. If you can make images not depend on scripts, that's great. If you can make one script not depend on another script, that's better. Basically, the more independent and siloed those components are, the better you can deal with this high packet loss environment, because the result is if one of those components doesn't show up, a packet loss causes a very long retransmission, and it takes a long time to get that single file back. You're not delaying the rest of your content. So when you talk about eliminating SPOFs or single points of failure, the most common ones you're dealing with are scripts. Scripts are by far the number ones, and you can use async JavaScript. I'll talk about that in a sec more. You can try to make push some of those scripts to the bottom of your page, or even explicitly register to the onload event and only run them there. CSS is a big single point of failure because CSS files block all rendering on the page until they're all loaded. You can try and either reduce the amount of CSS that you use, or only dynamically load CSS later if you can. Iframes fonts also have blocking behaviors. So all of those are components on the page that, if used wrong, could delay other resources and become a single point of failure. So you want to try and async them. I would focus on JavaScript and CSS first before you deal into with iframes or fonts, just based on past experience. And just to show a couple of slides talking about both the high latency and avoiding single point of failure, this is a slide showing the New York Times website loading on an iPhone over a mobile network speed. And what you can see here is the eventual, this is only async.js that's been applied here. It's only making the JavaScript asynchronous. And the effect of that is that the top one is the original page. If you look carefully, you see that around 8 seconds in, each one of these blocks is 2 seconds, a little bit of data shows up. And then 2 seconds after, a little bit more data shows up. And only 12 seconds in, the page is actually loaded. So the user is staring at a mostly blank page for a good 10 seconds. And that's because each one of these scripts blocks the rendering that follows it. If you made the scripts async, the page would actually load at around the same time, but the user experience is completely different. 4 seconds in or 6 seconds in here, they would actually be getting most of the content of the page. They can start interacting. They will stick around on this page. The user experience is much better. The waterfalls below show you how things are flat. They're just downloaded, no resources blocking others, versus the original case where they are blocking components. And this is just a similar piece of data talking about the correlation between latency and start render. So these are the top 10 mobile news sites measured over increasing levels of latency, and taking a look at when did the page start rendering. And you can see that as the latency increases, the blue line is the original site, where as the latency increases, the time it takes to actually start something, have something start render, increases significantly, while if you use async.js, that remains pretty flat. You get some content, you get the user the feeling that the page is loading much earlier, even in high latency networks. Okay, excuse me. Okay, so those were a couple of examples, and clearly there's more to talk about it, but those were sort of the key aspects of mobile network and how it's slow and what can we do to deal with it. Next up is mobile software, but before I do that, I'm going to take a quick look at the questions here. There's a lot of questions. I'm just going to pick a couple. Are there differences in the events reported in Waterfall Charts for mobile browsers versus desktop browsers? I'll talk about it in mobile software in a second, so I'll defer that a bit. But at a high level, I'd say mobile devices have browsers that are regular browsers, and they have some unique properties. But at the end of the day, they measure these events, these load times, about the same. Progress indicators vary from browser to browser, and that's true on mobile as well, whether it's a spinning circle or a progress bar or something like that. The waterfall charts are about the same, except the mobile measurements from Mobitest that I'm showing in some of these places are not as detailed as desktop ones. Question about the loading on demand. When people do scroll, won't those images mean very painful scrolling experience? So that's a very common question. Basically, when you load images on demand, you can basically on-demand or deferring images is basically the same thing, just about your decision. So what I'm saying is focus on loading the images that are within view first. After that, load the rest of them. Whether you're loading the rest of them, if you expect your users to scroll, then you're probably better off just deferring the load. So load the first and then right away go on and load the rest of the images. Using JavaScript, you can do that pretty easily, but you haven't delayed the original, the top, the more important images. If you don't think your users are going to scroll down or they won't scroll down far, then you can make those images load only as they scroll by listening to browser events. Either way, just don't let images that are below the fold slow down images that are above the fold. Okay, I will actually skip the rest of the questions for the sake of time, and I'll come back to all of them when we get to the Q&A. So this was mobile network. Let's dig a little bit into mobile software. So at a high level, mobile software is cool. It's good. It is new or newer than the desktop world or desktop browsers. Mobile browsers are designed for the web. They are designed for performance. The knowledge or the understanding that mobile browsing is going to be slow was understood from the very early days. So they try to adapt to all sorts of limitations in hardware network to provide better speed. They're generally more modern. Most of them have very good HTML5 support, CSS3 support, and they're just smart. They have all sorts of smart browser behaviors around look-ahead engines. They have good JavaScript engines. Those are improving. So in general, they're good. We like mobile software from the sense of the extent of support that they give us, the tools, the capabilities that they offer us. It is good. It's probably better. A mobile browser, on average, is often better than middle-age desktop browser. However, the mobile browsers also try to adapt to those environments, and sometimes they don't do it in a way that you as a website owner would necessarily agree with. Browser makers, and specifically mobile browser makers, make a lot of calculations about how they work. For me, at least, there's a couple of points here that I'll highlight that are important decisions they've made that affect your load time. The first one is that mobile cache sizes are too small. When I did some assessment of this a little while ago, measuring mobile cache sizes across Android devices, some iOS devices, and BlackBerry, all of them were very small. The top one was actually BlackBerry. That's the only race they won. And those ranged from 0 persistent cache to 25 megabytes. Memory cache is a little bit better, but if you close the browser process or you restarted your device, those would get cleared out completely. And either way, they're too small. Souders recently did some study that he got numbers maybe ranging up to 38. But when you look at average sizes today, if you look at the mobile HTTP archive, which I'd recommend, mobile.httparchive.org, you can see that an average mobile page size today is somewhere around 450K. So if you have 4 megabytes like you do on Android, you can barely fit 10 pages in your cache. That's very, very light. Even if you have 38 megabytes, that's very, very light. As soon as you browse 10 pages or maybe 20 or 30 pages, you're exhausting that cache and you're starting to re-download that data. So that's a very, very big deal. And cache is a very significant entity in making a website faster. You want to make your site cacheable, but it's pointless if the browser can't actually deal with it. So mobile browsers, while they give us very light cache, they actually give us something pretty good, which is local storage, HTML5 local storage. As I mentioned, mobile browsers tend to be very modern, and they have better support of HTML5 on average than desktop browsers. What the HTML5 local storage does is it gives you a website, a dedicated storage for your website whose size is about 5 megabytes. In some cases, it's half that because of 16-bit characters. So 2.5 to 5 megabytes of size, and it's yours. It's associated with your top-level domain, with your foo.com domain, and you can store whatever you want in there. So specifically, you can store files. You can store JavaScript files. You can store CSS data, and you can read it from save that data in that local storage and read it later on. Now, this data is dedicated to your domain. The user can go off and can browse a gazillion other sites and come back to your domain. That data would still be there. It is not easily cleared by the browser. In fact, it requires a user action, and in many browsers, even clearing that storage for the user is pretty hard to do. So it's a much better, or at least a much more predictable and robust storage location for you to use for storing your data. So local storage, using local storage is not as simple as using caching, but you can do that. I would recommend using it primarily for JavaScript and CSS, just doing the math around the impact byte for byte on performance. JavaScript and CSS matter more than images, and images change frequently. So I would recommend first and foremost using JavaScript and CSS, or storing JavaScript and CSS in local storage. And the link here is one that explains a little bit about how can you create a scriptable cache that has step-by-step instructions on how can you use local storage to cache some of your information. I believe we also have a webcast around that in about a month. So it really is significant. A very side note is that if you do cache items, try to use a far future expiry dates. At least on Android, that would make these files take priority in the cache eviction policy. If Android needs to clear one of two files and one of them expires further out in the future, it would prefer that file. So cache sizes are small. Local storage is a possible solution for it. As a side note, it's unclear why our cache size is that small. There's a whole bunch of theories talking about writing to flash memory again and again, and there's a lot of countering theories saying that that doesn't matter. Bottom line is we don't know exactly why our cache size is small on mobile, but we do know that that is the case and that it really hurts performance. The second attribute I want to highlight around mobile software is pipelining. HTTP pipelining is a pretty old notion. It's been around since HTTP 1.1 was created, I believe. And the idea is pretty simple. It says send multiple requests on a single connection before receiving a response. So in a regular scenario, as you can see in the illustration on the left, the browser on a given connection would send a request, wait for the response, send a request again, wait for the response. And in a high latency network, that is very, very costly. If it takes you a third of a second to interact with the server, every time you're sending a request and receiving a response, you're paying a third of a second. The idea of HTTP pipeline is send 3 requests at once. You still need to wait for the 3 to come back, and they have to come back in order. But at least you don't wait for the response and then send the request. You saved some time there. If all of those responses came back in, let's say, 0 time, if they were very, very quick to get back, then when you send, and it took you a third of a second to communicate with the server, you will get all of your information in about a third of a second instead of all of your information in about a second. So it really is significant in high latency networks. Mobile browsers acknowledged that, and HTTP pipelining is used in the vast majority, or in all the primary browsers in the mobile world today. In Android, Opera browser, which is used a lot around the world, and in iOS, since iOS 5 in iOS as well. And to contrast that, on desktop, it's hardly ever used. Firefox supports it, but it's off by default. Opera has it on by default, but it's a very small browser on desktop. And that's due to some problems I'll talk about in a second. So it's an important distinction between how mobile browsers work and desktop browsers work. So what should you know about pipelining? What do you care? So the biggest problem or risk with pipelining is called head-of-line blocking. And that's the idea that, hey, I just sent a request for 3 resources. Now I will not get a response to 2 and 3 until the first one completes. I made a request to 3. Let's say it took a long time for the server to process and create and start sending back the response to the first. The other 2 are just sitting there waiting in the queue. If I wasn't using pipelining, the browser uses multiple connections. So eventually, one of those connections would free up, and I would send those requests 2 and 3. So the concern that's called head-of-line blocking is that a slow resource will delay fast resources. And that's the primary concern being voiced when you talk about why did desktop browsers not adopt it. So that's the primary risk. There are some other complexities about the order of requests, but those are more elaborate. The other thing to know about pipelining is that it depends on heuristics. So there's some logic that the browsers apply to try and assess whether the server supports HTTP pipelining. The browser needs to decide, can I send multiple requests? And generally speaking, they look at whether your server is returning an HTTP 1.1 response and whether it's using a keep alive connection. And if those two are there and you have an explicit connection, you generally get pipelining. It would be established that the server supports pipelining, and it'll be used. The last thing to know is that it does conflict with domain sharding, which is a separate optimization that deals with opening more connections. It basically leads the browser to open more connections to the server, which to a certain extent conflicts with pipelining. So there's a link here to a lot more information about it. But really what you want to do, if I'm to skip over, this is actually just a screenshot of network capture from the Galaxy S. And it's just sort of some eye candy here where you can see about 6 requests being made at once without a response in between, just submitting all of those requests at once. So pipelining is a very elaborate topic, and in those 2 slides I had links to more detailed information in our blog about it if you want to read detail. But really what you want to do is you want to make sure your server supports HTTP pipelining, which is almost a given unless you're using something very, very old. And to avoid the head-of-line blocking concern, what you could do is you could use separate domains for slow and fast resources. For resources like static resources, the JavaScript files, the images, maybe if you're using a CDN, you even expect those to be on the CDN, on the content delivery network. You can use and serve all of those resources from fast.foo.com, and then put all of your servers that make all of the requests that may lead to heavy database queries or that are dynamic in nature on your www domain or on a separate domain. So you don't need to do a clean slice, but if you can easily segment those that are fast and separate them out, you're reducing the risk of head-of-line blocking. You definitely want to use connection keep alive, which is good anyway, but it's especially important on mobile. And you want to use domain sharding carefully, if at all. Ideally for mobile, the simplest optimization I would say is just don't use domain sharding for a variety of reasons. Okay. So I'm already behind. My time management skills could be better. I'll take a quick glance at the questions, but I may just defer those questions to the end. See if anything. So a couple of quick ones. How many concurrent requests will mobile browsers support, same as desktops? I'd encourage you can go to browserscope.org to get detailed answers, but at a high level, Android defaults to a very small number of connections, about 4 in the stock Android, although different manufacturers like Samsung may increase that number. Most of the other platforms act similar to desktop. So iOS, for instance, opens many connections, up to 32 or maybe 60 actually in the latest version. Mobile cache size is too small. What was the reference given? Yeah, so sorry, I'll repeat that. So specifically around mobile cache sizes are too small, we will give out the slides, and they have a link to post on the blaze.io/blog that measure the actual cache size. What I was mentioning is mobile.httparchive.org, which is a website that repeatedly measures a certain set of websites using an iPhone, and that's the mobile version. And it aggregates or shows data about what makes up those pages. So specifically, you can get stats like what's an average mobile page size today. How secure is local storage data? It is very secure. It's subject to same origin policies. It's basically just as secure as most other things in the browser. Okay. I'll actually skip the rest, and I'll just glance over them again when I get through, so I make sure I get through the next section. Okay, so we talked about mobile networks, that it's slow, and we got a little depressed, and we talked about mobile software, which is awesome, and it has a couple of things that we need to know about, the cache sizes, which are less exciting, and the pipelining, which is just the difference we need to know about. Last up is mobile hardware. So mobile hardware is also different, and it has a couple, as before, I'll talk about a couple of primary characteristics. First off, it has a weaker CPU. So mobile devices are not as powerful as your laptop or as your desktop. Specifically, when you talk about less computation power, the immediate equation is that it means slower JavaScript. When you run the SunSpider benchmark, which is one way to measure JavaScript performance, even when you run it on the latest devices, you're still getting performance that is 10x slower than what you would get on an equivalent desktop or an equivalent laptop. Your desktops would probably perform even better. So it means that you need to worry about JavaScript more. It's important to note that when you have a large JavaScript library, even script parsing can be slow. Depending on the library, a good estimate is it'll take between 1 and 10 milliseconds per kilobyte of script, uncompressed, to parse the script on a mobile device. So you want to be careful about not putting too much script as well, partly because of CPU concerns. And the CPU concerns are not just around JavaScript, although JavaScript is the most immediate one. They also apply to Flash for those devices that support it, for dynamic CSS or CSS expressions, for graphics that are elaborate, for reflows. So you need to be aware of the fact that the browser is, the device is weaker. Now, there's a common misconception that, sorry, just moving slide, that these types of concern and the JavaScript concern is only applicable to these apps, these AJAX applications that do sophisticated JavaScript, and that is not the case. What you can see on this slide is we took the top 100 websites in the US based on Alexa's index, and we measured them all over iOS using iPhone 4, iPhone 4S, and iOS Simulator. So the iOS simulator is designed such that it actually uses the hardware it runs on. It doesn't try to simulate mobile hardware. So basically, we're using the same software on the iPhone 4, the iPhone 4S, which has double the CPU but is otherwise similar, and on the iOS simulator on a significantly more powerful device. And this is just the top 100 websites and just loading, so it's not significant JavaScript actions or not unique JavaScript actions. And you could still see that even the doubling the CPU to 4S created a significant improvement in load time, going from 3.4 to 2.9 average, and then going to the simulator doubled or halved that speed again. So it is significant, and it does matter to your site, even if you're not doing something extremely elaborate with JavaScript. So you want to know about JavaScript. I repeatedly forget to add a slide here about what you can do about it. So the primary thing here is just to be aware of it, to try to avoid sophisticated JavaScript. The other suggestion I have here, which is maybe more practical or more immediately applicable, is using asynchronous JavaScript or deferring JavaScript. JavaScript is going to run more slowly. That's going to have a bigger effect if it also delays the other components on your page. So sometimes you can't do anything about the fact that JavaScript is going to run slowly, but you can just put it at the bottom, delay the execution of it, just like you would delay the downloading of it to avoid that getting in the way of other components. If you can do it late, don't let it slow down the entire page. So that was point one about hardware. And the last point I'm going to talk about hardware and these components in general in this presentation is the form factor. So if you haven't noticed, mobile devices are small. Kind of comes with a territory. Can fit in your pocket if it's laptop size. Really, we're talking about two main sizes. We're talking about smartphones ranging from roughly 2.6 inches to about 5.5, which is a pretty hefty phone. And we're talking about tablets, the 7, 10-inch tablets. So this is a clear distinction. Remember, what we're talking about primarily is how does mobile differ from desktop and how does that affect performance. It's clearly a difference between mobile and desktop, but what is a design challenge, it's hard to really make your site work well on all these devices is really an opportunity for us for performance. A smaller screen size means you don't need as much data to populate that device. You can actually serve less content, serve less stuff. So this is an opportunity that we have, and the device or the primary action you want to take is you want to take advantage of it. The easiest or the most commonly used technique to take advantage of that is called responsive images, which is the idea of responding to the screen size and downloading an image that is resized to that screen. Or a better term is probably resampled for that screen. So if you're loading a very big image on a 480 pixel wide screen, and your image has 4,800 pixels in its granularity, the user is not going to appreciate that data. You can't see it on that screen. So the resolution of the screen and the width of the screen to a certain extent, but primarily the resolution, is a certain limiting factor in how much they can appreciate a more accurate, a bigger image. So what you could do is you could resize those images to match the different display sizes. This is an example on the Lonely Planet website where if you can take the original image, which was about 50K, and if you resize it down to a width of 480 pixels, which I believe is the iPhone 4, 320 pixel wide, which is the iPhone 3GS, and further down, you can see that you can cut down that size by 60% and then half it again, and then go smaller and smaller from there. And for the entire page on the Lonely Planet website, that resulted on an iPhone 4 in a page that was about a third of the size. The page was about 2/3 of the size. You lost about a third. You saved about a third. So this optimization is very significant. It can shave a lot of bytes. Most of the bytes on your page are images, and therefore if you reduce the size of the images, you reduce the size of the page considerably, and you improve the load time quite a bit. But there are many techniques here. I should add the link here, but if you go to cloud4.com, that is they're a mobile design shop. They have a blog that has very good details about responsive images and how you can apply them. One technique you could do is you could just save a few different versions of your images on your server. Every time you have an image, just create 4 or 5 different resolutions of it, and then using JavaScript on the client side, choose the one to download. Not necessarily trivial, but not the end of the world either. jQuery has a bit of a library, that can help with that a little bit as well. Okay, so let's summarize a little bit what we talked about. We're about 10 minutes from the top of the hour. So we talked about mobile. Mobile is too big of a term, so we take mobile and we split it up into mobile network, mobile hardware, and mobile software. And in each of those, we dug in a little bit and we tried to understand what are the differences between this mobile X and the desktop equivalent. And for those, what are the performance implications and what can we do about it? And we really highlighted a couple of challenges for each of these 3 categories. We talked about the slow and unreliable networks that can be helped by reducing the sizes, the complexities of our page, and by trying to make as much as possible each individual component on our pages independent, specifically using asynchronous JavaScript. We talk about mobile hardware, which is not as powerful as your desktop or laptop hardware, but it has a smaller screen. And with that, you can, from the weak CPU perspective, that is a limitation. We should try and make scripts async or just try to avoid them altogether. The small screen is an opportunity. We should take advantage of it with responsive images. This is a typo here. And try to serve a smaller image to a smaller screen. And then we talked about mobile software, which we like and we're big fans of, but it has a couple of specific characteristics. The smaller cache that we can help overcome using local storage, and the use of HTTP pipelining, which is more of an awareness, and we can do some things to reduce risks. I'll switch to questions in a moment, but before I do that, the last point I want to leave you with is don't assume that practice A is better than practice B. All of this presentation talked about generic assumptions. For each individual site, for each different context, not all of them may be applicable. One thing might be better than another. So you really want to, first of all, design what is right for your site. And secondly, you want to measure. Measuring, if you don't measure your performance, you don't really understand what it is. There are many different techniques to measure. Specifically, I would point out a few here. You can use Mobitest, which is the free service that I mentioned earlier, where you can just measure any given URL over a variety of devices and get some results, or you can install it on your own devices if you want to take it a step further. Google has a great tutorial and tool to try and sniff and capture network traffic from your device called PickUpPerf. If you go to pickupperf.appspot.com, it has great instructions on how to do that, and then it can convert it into this waterfall chart like Mobitest provides. And then a couple of other tools you can use for iOS. The tool called IC, that is sort of an HTTP viewer, and Maximiliano Furtman, also known as Furt, has a tool called iWeb Inspector, which is really a debugger, not just for performance, but it also gives you great insight for performance. So those are good solutions. There's also real user monitoring and other attempts at capturing load times from your real users, but that's probably a whole conversation topic by itself. So don't assume anything. Try to measure those components and really understand what your performance is like. Okay, so with that, I will go over some of the questions that are here that I have not yet answered. Let me start from the bottom. Sorry, I'm just skimming over. Any way to adjust content density depending on connection quality on the fly? Ooh, that's a tough one. The short answer is no. The closest thing that you have for that is on an Android device, you can separate whether you're on Wi-Fi or 3G or 4G, and you can use that indicator to choose to do something one way or another. It's nowhere near as accurate as just saying what is my network quality. But it's basically the best you've got right now. So beyond that, you should kind of assume the worst. When we talk about loading images on demand and reducing quality of images maybe to optimize for a slower network, what you could also do is assume the worst and then progressively improve. So for instance, download low-quality images and then have scripts that in the background, after the page is loaded, downloads the high-quality images, or things of that nature where you start with assuming the worst and then improve if possible. This is already answered. How would you recommend HTML5 mobile animation creators optimize? I don't have a good answer for that. I know that Chrome on desktop has some really good analysis tools for performance inside the browser. I think those are still quite short on the client side. So I would just, if you can do it in load time, you can use one of the tools that I mentioned. If not, maybe iWeb Inspector would help, but that's only on the simulator. It's a tough one. I don't have a good answer. You may want to tweet at Paul Irish. He might have a good answer for that. When testing for mobile perf, is testing on real carrier networks useful, or is the performance too variable to be actionable? Very good question. So there's a lot of, when you talk about mobile networks, volatility is one of the properties as well. The fact that the performance from in a given network in different locations, different times, different loads can vary dramatically. If you do measure over a real carrier network, you should try and get a large sample set. At the very least, measure over a large span of time. Don't assume too much because of a single measurement in time. On the flip side, if you measure over a simulated network, or if you measure over just a broadband or Wi-Fi, you're going to get more consistent results, but they're not necessarily the most representative results to what your users are acknowledging. So basically what I would say is measure, my recommendation would be, if you can, measure over a 3G network, over a real cellular network, try to get at least 2 locations and measure over time. And then when you look at that, look at sort of the 95th percentile or look at something of that nature, because many of your users are going to be experiencing the low quality as well. So try to understand what is the low performance as well for the network. Try to understand what is the user experience in those cases. In the New York Times example, was the JS placed in the footer? No, the non-async version had a lot of the components in the top, but a lot of times with ads, if you want to place them anywhere specific in the page, you can't always just push them down. Some ad networks allow you to do that, others do not. So in that case, you had ads at the top. They got created using document.write, which ads often are created that way, and therefore you had to place them at the top as well. And design pattern that may be out there for achieving better mobile web performance. I think all of these are recommendations. There's no real design pattern. In general, so when you talk about mobile design philosophies, there are three primary categories. There is the m.dot site, where you have a separate site for mobile. There is the sort of graceful degradation, where you start from a rich site and you hide and remove components from it using CSS and JavaScript tricks. And there is what's called mobile first with progressive enhancement, where you start from a very lightweight website and you tack on content as it's available. For performance, the best performance is usually with m.dot sites because they're dedicated, but they are usually the hardest to really maintain. I would say either an m.dot site or a mobile first with progressive enhancements are the better performance options. There's a lot of conversation about philosophy and what's the best design. Maybe I have time for one more question. Apply delay load, another mobile optimizations method to desktop. No, most of the optimizations that I've recommended here are not bad for desktop. You can usually do all of those in desktop as well. They may affect your user experience, but they're good practices to do on desktop as well. So usually if you build them, you do want to apply them to desktop as well. The exception are things like responsive images or the dealing with HTTP pipelining. Those components are usually not detrimental. Either they're not applicable to desktop or they don't hurt you, but they don't help you either. Not sure I'm going to continue until somebody shuts off the webcast here, but is there a way to separate content expiry headers specifically for mobile browsers? You can set different headers based on the user agent. Mobile browsers, at least iPhone and Android, are easily identified by just looking for the words iPhone, Android, iPad in the user agent. So you can do these types of big distributions pretty easily if you're not trying to really tailor yourself to a specific device or resolution. I highly recommend doing that. We use a technique similar to that in our optimizations. Any solutions for dynamic pipelining? Pipelining is pretty straightforward. It's not very sophisticated. Speedy is a more sophisticated version for it in the newer browsers. But at a high level, you don't control how the browser does pipelining. All you can do is try to put your resources on domains that have consistent or predictable performance. The browser would not pipe requests to different hosts on the same connection. Which is more effective, domain sharding or HTTP pipelining? Domain sharding is anywhere between not useful to hurtful on mobile, but it is useful on, at least having two domain shards is useful on desktop in many, many cases. So HTTP pipelining is a browser decision, so it's very separate. I would say try to only apply domain sharding if it's not a mobile device. So if it's iPad or Android or iPhone, don't domain shard. Anywhere else, domain shard. If you can set that up, that would be ideal. It's a tough choice about saying whether if you can only do one, whether you should shard or not with the risk of pipelining. It's a tough call. Like a very generic statement, I would say is maybe do sharding to two domains, but not more. But really, I would encourage you to measure that on your site. For the hardware impact, what kind of connection was used for page load times, Wi-Fi or 3G? Yeah, I glanced over it. It does say in the slide that we used a fast network connection there. So it was over Wi-Fi at nighttime. So the idea was to try and neutralize the slowness of the network and just look at how long does it take to load on a weaker device the same page as on a fairly consistent and high-speed connection speed. avoiding complicated JavaScript. What JavaScript-based framework would you use? JQM, Sencha, etc. You shouldn't avoid complicated JavaScript. You can do rich and amazing things with complicated JavaScript. But what I would recommend is just think about when is it loaded and what is the user experience until that time. If you have a very rich application, I would recommend making the loading of the page not depend on the heavy JavaScript platform. Load something, load a template, even a page that says loading, although users find that somewhat annoying. Try to load something so that the user would see something quickly, get something responsive from you, and tell them that what you're doing now is you're loading the application. Put a splash screen of sort in front of them, as opposed to letting them stare at a blank screen until you downloaded the whole component. So that would be at least my, it's a semi-design philosophy, but try to just be fast to give them something. Then one last question. If jQuery mobile something you could recommend without ever working on it, appears to have a lot of overhead by what I've read. jQuery mobile is a UI framework as opposed to jQuery desktop. It's not the same at all. jQuery itself is a pretty lightweight library. I don't think it's a big deal if you use it on mobile. There's a library called Zepto, which is meant to be jQuery Lite, Z-E-P-T-O. So you can try to use that. That one specifically doesn't seem to be too bad. I would encourage you to, whatever framework you use, and I don't know if I have a specific one that I'd recommend. I talked a little bit about the load ordering. Whatever framework you use, try to see, A, if it has a specific mobile version, and B, is how big are the files that they're downloading, and try to have a rough assessment or feel for how much of that is, if you're using the same platform that is used for desktop and mobile, how much of that content is really needed on mobile, or can you shed it? There are many, many different platforms out there, so they're not, it's hard to really recommend one versus the other.